Let's start off with the definition of the imaginary number I. If we had the square root of 4, there's two ways to get that. Let's say I had minus 2 times minus 2, or I had positive 2 times positive 2. Either of these would yield the 4, but if under the radical, let's say that I had the square root of minus 1, well, the square root of minus 1 would be 1 times minus 1, but these are not the same number. These are two separate numbers that are two spaces apart on a number line. So if I had minus 1 times minus 1, that would give me a positive 1. And if I had positive 1 times positive 1, that would also give me a positive 1 under here. So there are no two numbers where if I multiplied them together would give me the square root of minus 1. Yet, the square root of minus 1 in math is defined as the letter I. Let's look at some of the characteristics for I. If I had I to the 0 power, anything raised to the 0 power is just going to be 1. If I had I to the first power, well, that's just I, it's itself. For I squared, that's the definition of I is the square root of minus 1 times the square root of minus 1. Well, the square root of anything times the square root of anything is just whatever's under the radical. This would be minus 1. For I to the third power, that's the same as I to the first power times I squared. And this would give me I to the first power is the square root of minus 1 times, and then I squared is minus 1. So this would be the same as minus I. And then I to the fourth power is going to be 1. And the reason why, if I have I squared, which is minus 1, times I squared, which is also minus 1, well, minus 1 times minus 1 is positive 1. We see going from I to the 0 power down to I to the fourth that this is cyclic. I to the minus 1 power is the same as 1 over I. This one ultimately would be minus I. And I to the minus 2 power is 1 over I squared. And I squared is minus 1. So this would be 1 over minus 1. So this would be minus 1 for the final answer. This one would just be I, positive, positive. And I to the minus 4th power, 1 over I to the 4th power. Ultimately, this one would be 1. Looking at the first example, the square root of 8, this is the same as the square root of 4 times the square root of 2. And then I can take the 4 out from under the radical. It would just be a 2 and times radical 2. It works similarly when we work with the imaginary version. This time we have a minus sign that's under there. And I want to keep the minus with the radical that's going to be able to be simplified. So this would become radical negative 4 times radical 2. And then this here, the 4 can come out, but so can the minus sign. So this would be 2i radical 2. So if we're going to simplify here, we notice that we have minus signs underneath the radicals here. And we're going to simplify what we're able to first. So the square root of 100 is 10. I can't simplify that yet. I can simplify the square root of 25 is 5. And I'll bring the rest down. Now, the square root of minus 2 can be simplified by pulling the I out and leaving radical 2 alone. And I bring down the 5. The square root of negative 128 can break down into radical minus 64 times radical 2. The radical 64 can be simplified to be 8i radical 2. Now we combine like terms, the 10 and the 5. Is 15, and I have 8i radical 2 minus 1i radical 2 is 7i radical 2. And that is the final answer. Here we have a negative right at the beginning. We'll just bring that down. The square root of 49 is 7 plus Now, the square root of minus 7, I can take out the I. I'll put a 1 in front of it. And then this just becomes rad 7. Then I have a minus sign, and square root of 81 is 9. And then over here, I put a plus. This is divisible by 7, and 7 times 25 works. And since I want the 7 to remain in, I'll put the 7 here, and then I'll put the minus 25 over here so it comes out with the I. Rewriting the next line and taking the 5i out from under the radical, then I have times radical 7. And now I just combine like terms. The minus 7 and minus 9 can be combined. And then I have plus 1i rad 7 and plus 5i rad 7 is going to be plus 6i radical 7, and that is the final answer. Let's try an example where we're multiplying. When you're multiplying, the first thing you do is you go left to right. Looking at the radical 6, there's nothing that I can do with that, so I just bring it down. For 4 radical minus 9, I bring down the 4. And then I see that for radical minus 9, 9 is a perfect square, so I can bring the 3 out, and the square root of minus 1 is I, so I bring that down. Now I'm going to simplify because I can multiply 4 times 3i, that's 12i. And the only thing left is radical 6. And that's the final answer. This next example actually kicks up the difficulty because now I'm multiplying a minus 2 times a minus 5, so I'm going to have I 2 times. And then for the radical minus 2, that simplifies to be square root of minus 1 and the square root of 2. And then for the last term, the square root of minus 5, I can simplify that only to be the square root of minus 1 times the square root of 5. Now, the square root of minus 1 and the square root of minus 1 are both I. And if you remember from earlier in the video, I times I is I squared, and I squared is equal to minus 1. So I'm going to rewrite this, changing the I squared to minus 1. Next, I multiply minus 1 times minus 1. Well, we don't need the times 1 there anymore, so we'll get rid of that. And we can simplify radical 2 times radical 5. Remember the rule. Radical A times radical B equals radical AB. So I can multiply them. And my final answer is radical 10. In this next example, I have radical minus 10. I can only take out the minus 1, so the next line. And the 6 radical 90 simplifies to be 6 radical 9 times radical 10. Now I can simplify the 6 radical 9. I can take out the square root of 9 as 3. So the square root of minus 1 is 1i, rad 10, and the 6 times 3 is 18. I can multiply 18 times 1i is 18i. And the square root of 10 times the square root of 10 is 10. So then I simplify 18i times 10 is 180i, which is our final answer. Here I have 5z minus 4i and the entire thing squared. That's the same as 2 binomials. And to multiply these, we use FOIL, so 5z times 5z. Then I have 5z times minus 4i, that's minus 20zi. And then again for the inner terms. And then for the last terms, a minus times a minus is a positive. 4 times 4 is 16. I times I is I squared, and I squared is minus 1, so we'll put a minus 1 there. Simplifying on the next line. Minus 20zi minus 20zi is minus 40zi. And positive 16 times minus 1 is minus 16, and this is our final answer. Before we begin this next example, if you haven't already done so, please like and subscribe. It would really help my channel out a lot. And if you need a video made on any topic, just go to the comments below and let me know what the name of the video is, and I'll jump ahead of the schedule of the order I'm making the videos in to get yours up. This problem has 2 sets of binomials that we need to simplify. So let's take the one on the left first. So I have the first terms, 3 times 5. Then the outer terms, 3 times 3i is 9i. Then the inner terms, minus 2yi times 5 is minus 10yi. And then for the last term, do sine times sine, number times number, letter times letter, we didn't use the y, and then I times I is I squared, so that's times minus 1. And then I bring the rest down. Now in this term over here, I have minus 6y times minus 1. That turns it into plus 6y. So I'll bring the first part down, then I'll simplify the second. In simplifying the second part, I want to distribute this minus 1 to the first binomial. So I get minus 3 plus 2yi. And then I want to multiply the minus 3 plus 2yi times 5 plus 4i. So I do the first terms, minus 3 times 5. Then the outer terms, minus 12i. Then the inner terms, that's plus 10yi. And then finally the last terms, which would be 2 times 4 is 8y. And then I squared is minus 1. That minus 1 makes it minus 8y. And now to simplify, I'll go left to right and I'll combine like terms. I have plus 15 minus 15 add up to 0. And I have minus 10yi and plus 10yi, they add up to 0. And then plus 9i minus 12i add up to minus 3i. And finally, I have plus 6y minus 8y is minus 2y. And this is our final answer. One last type of example that I'd like to look at is one where you have substitution. So here we're given ab squared, and we're told that a equals 5 plus 5i and b equals minus 2. So I rewrite ab squared substituting a and b. So since there were no parentheses around a and b, it's only the b being squared, so I'm going to square minus 2 for the next line. And then I can distribute that 4 to the two terms. So I get 5 times 4 plus 5i times 4. And I get 20 plus 20i as the final answer.